Hello and welcome to USGS Corecast. I'm Jessica Robertson. Today's Corecast is the first of a three-part series on recent USGS-led reports on climate change, which were developed under the U.S. Climate Change Science Program. The report we will be discussing today focuses on past climate variability and change in the Arctic and high latitudes. Temperature change in the Arctic is happening at a greater rate than other places in the Northern Hemisphere, and this is expected to continue in the future. A new scientific synthesis of past Arctic climates demonstrates for the first time the pervasive nature of Arctic climate amplification. Today, I'd like to welcome and introduce you to our guest, USGS scientist Joan Fitzpatrick, who was the agency lead for this report. Thank you for joining us today.
Thank you for inviting me to do this, Jessica.
First, can you provide us some background information and an overview of this report?
Sure. This particular report is a synthesis of what's currently known about past climate history of the Arctic. And specifically, the report focuses on the past history of temperature and precipitation changes in the Arctic, changes in the Greenland ice sheet, past rates of change, and changes in sea ice. Now, the focus on past rates of change is actually shared with the single topic of another one of the USGS-led reports, which is entitled Abrupt Climate Change. This report is one of 21 climate reports that were commissioned in the strategic plan of the U.S. Climate Change Science Program, or CCSP. The general purpose of these reports is to provide the nation's policymakers with in-depth assessments of specific topics in climate change that touch upon the national interest. And they cover a broad diversity of topics, everything from the impacts of climate change on agriculture and land and water resources and biodiversity to the strengths and limitations of climate models. The USGS has a lead responsibility for 3 of these assessment reports.
And what were the key findings of your report, focusing on past climate variability in the Arctic?
Well, we had key findings related to each of our 4 technical areas. For Arctic amplification, we found that this process, which is the process by which the high northern latitudes respond more intensely to hemispheric or global climate changes, has been a pervasive feature of the Earth's climate system for at least the last 4 million years during both warming times and cooling times. Therefore, we can anticipate that continued warming at mid-latitudes will result in even more warming in the Arctic, and that this will lead to continued increases in glacier and ice sheet melting, coastal erosion, permafrost degradation, loss of summertime sea ice, and all of the downstream impacts associated with that. For the sea ice findings, we found that taken together, when you look at both the size and the speed of the current loss of summer sea ice over the last few decades, it's really very unusual compared to the events in the record from the previous thousands of years, especially when you consider that changes in the Earth's orbit over this same period of time have really made sea ice melting less and not more likely. For our Greenland ice sheet segment, we determined sustained warming of at least a few degrees, more than about 4 degrees Fahrenheit and up to about 13 degrees Fahrenheit, above average 20th century values, is likely to be sufficient to cause the nearly complete eventual disappearance of the Greenland ice sheet. And this, of course, would raise sea level by several meters. Our rates of change finding is that the current rate that we're seeing now of human-influenced Arctic warming is comparable to the peak natural rates that are documented by reconstructions of past climates. However, we do note that there are some projections of future human-induced change that actually will exceed the documented natural variability. Finally, for our rates of change segment, we find that the past tells us that when thresholds in the climate system are crossed, that climate change can be very large and happen very quickly, and that we can't rule out that human-induced climate change could potentially trigger such an event in the future. And I'd refer your listeners to the assessment report on abrupt climate change that was recently also published by CCSP for more information on this.
Now, why exactly did you focus on the Arctic? What's the significance of this area?
Jessica, the Arctic has very strong feedback mechanisms that act to multiply the effects of overall hemispheric or global temperature changes. And these are the source of Arctic amplification itself, the phenomenon itself. The presence of a highly reflective insulating snow and ice cover, the existence of a large body of land ice, that is the Greenland ice sheet, the existence of perennial and seasonal sea ice cover blanketing the Arctic Ocean and insulating it, and the existence of extensive permafrost, the freshwater input balance, and ocean circulation. These all factor into the Arctic's enhanced capability to both respond to and to, of itself, drive the global climate system.